Hello students, let us start with a new concept called as understanding elementary shapes. This is the fifth chapter in your NCERT textbook. There are so many shapes around us made of lines, curves like line segment, angles, triangles, polygons and circles, etc. These shapes are of different sizes and measures. Line segment, angle, triangle. We organize them into line segments, angles, triangles, polygons and circles. We can see that they do not have the same measure. So it is necessary to develop tools to compare their sizes. How do we measure the line segment? A line segment is a fixed position of a line, so we can measure a line segment. The distance between the endpoints of a line segment is called its length. The measure of a line segment is a unique number. Actually, the measure of the line segment is called its length. It helps us in comparing two line segments. This can be done in several ways. The first way is to compare by observation. The second way is by tracing. And the third way is using a ruler or a divider. Let's see one by one. How do we compare by observation? Comparison by observation. We can tell which line segment is greater than the other just by observing the two line segments, but it is not sure. Suppose if I have the two line segments AB and CD here, we can easily say that the line segment AB is greater than the line segment CD. But sometimes it is difficult to tell which one is greater. Actually, we represent the line segment in this way. Line segment AB greater than the line segment CD. But every time it is very difficult to tell which one is greater just by observation. The second method is followed then. The second method is comparison by tracing. This method, we have to trace one line on a paper, then put the traced line on the other line and check whether which one is greater. But this method is difficult method because every time to measure the different size of line segments, we have to make a separate line segment. So we follow the third method. Third method is comparison using a ruler and a divider. We can use ruler to measure the length of the line segment. We have done it in our lower classes. We take the ruler, we follow certain procedure. We will put the 0 mark at point A here and then move towards L to measure the length of the line segment. But it may have some errors on the basis of the thickness of the ruler and also the thickness of the line segment. So we will make use of a beautiful instrument called as divider. This could be made accurate by using a divider. What are the steps to be followed to use the divider? The steps that are to be followed are: put one end of the divider on point A, then open it to put another end on point B. Now pick up the divider without disturbing the opening and place it on the ruler so that one of its ends lie on 0. Read the marking on the other end, and we compare the two line segments in this fashion. Look at this figure. Here a line segment AB is to be measured, so the ends of the compass, so ends of the divider, are placed at A and B. Then using the ruler, one of the end is placed at 0, other end is placed at ruler. Other end gives the measure of the line segment. If it is say 5, it gives 5 centimeter as the measure of the line segment AB. So we can say that the line segment AB measures 5 centimeters. This is all about the line segment. At this stage, I would like to revise a concept called as line, ray, line segment. First, let me take a line. Usually, a line is represented using two arrows. These two arrows indicates that it can be extended on either side. When it is extended on either side, we can say that there is no end points. So the line cannot be measured. It cannot be measured. If I mention a letter here, you will read this as line L. Other way to represent is, on the line we will mark 2 points and we read it as line AB, and it is represented as AB. Over that, a small symbol to represent the line. It is read as line AB. This is all about the line. What you must understand is a line cannot be measured as it has no definite length. Now let me consider a part of the line. This is called as a ray. This is a part of line which has one end point. This fixed point is called as a end point. Suppose if I mention AB over here, point A is fixed and point B is not fixed. We represent this as AB, and that a small symbol to represent the ray. It is read as a ray AB. Can I measure the ray AB? No, it cannot be measured. Why it can't be measured? Because one of the end can be extended on one side. So it has no definite length. This is all about a ray. Now let me consider another part of a line, which is called as a line segment. This is a line segment. A line segment will be having two ends. It can be measured. It has definite length. So only in our discussion we had the measuring of line segment, not the line or not the ray. We have compared two line segments, not two lines. We can't compare the lines. So for example, if I consider this as a line L, this as another line, say M, should I say that line L and line M, they are equal? I can't say that because we are not sure about the length of the line. As the line can be extended on either side, we don't have the specific or definite measure, so it cannot be compared. So is the case with a ray. A ray AB cannot be compared with another ray, say PQ. It cannot be compared. However, two line segments, say line segment AB and line segment, say XY, can be compared. Now I have made it clear that why a line or a ray is not considered under measuring topic. The next concept is all about the angles. First we will discuss the meaning of right angle and straight angle. We can understand this concept of right and straight angles by directions. Look at this. Here N represents north, E represents east, W for west, S for south. These are four directions: north, south, east, west. When we move from north to east, then it forms an angle of 90 degrees, and this angle is called right angle. When we move from north to south, it forms 180 degrees, which is called as a straight angle. When we move four right angles in the same direction, we reach back to the same position again. That is, if we make clockwise turn from north to reach north again, then it forms 360 degrees, and this angle is called as complete angle, and we get one complete rotation. You have understood the difference between right angle, straight angle, and a complete angle? Now I want you to observe this clock. In a clock, there are two hands, that is, a minute hand and hour hand, which moves clockwise in every minute. When the clock hands moves from one position to another position, it goes through an angle and it forms some angle. Here you observe, when hand starts from 12 and reaches 12 again in one complete revolution, 360 degrees is formed. Suppose if half a revolution is done, we get two right angles and it forms 180 degree. Here in one revolution we get 360 degree. If 1/4 of the revolution is made, we get one right angle and it is equal to 90 degrees. That is, when our hand is from 6 to 9, the angle formed between these two will be 90 degrees. From 1 to 10, 3/4 revolution, we get 3 right angles, hence the angle formed will be equal to 270 degrees. Now I want you to look at the next topic called as types of angles. We have seen a right angle and straight angle followed by complete angle. Not only those angles, there are other types too. What are they? The next type is acute angle. An acute angle is an angle smaller than a right angle, and this acute angle is less than 1/4 of revolution. Look at this figure here. The angle measure is less than 90 degree. Here I can write angle measure less than 90 degrees. Next we have obtuse angle. An angle larger than right angle but less than straight angle is called obtuse angle. An obtuse angle is greater than 1/4 revolution but less than half a revolution. Look at this figure. Here angle measure is greater than 90 degree but less than 180 degree. Next we have reflex angle. A reflex angle is larger than straight angle. Look at this figure here. This angle measure is greater than 180 degrees. Next concept is to measure these angles. To compare the two angles exactly, we need to measure those angles. This is done with the help of a protractor. One complete revolution is divided into 360 parts and each part is called as a degree. Remember, each part in 360 parts is called as degrees. The measure of angle is called as degree measure. We write 360 degree as symbolically 360. Over that we use symbol, it is read as 360 degrees. Now we will learn how to measure the given angle. By observing an angle, we can only get the type of the angle, but to compare it properly, we need to measure it. The angle is measured in terms of degrees. One complete revolution is divided into 360 equal parts. Each part is 1 degree. We write 360 degrees and it is symbolically written in this way, and it is to be read as 360 degrees. We can measure the angle by using a device called as protractor. In your compass box, you must have observed this particular instrument. It has a curved edge which is divided into 180 equal parts. We start from 0 degree to 180 degree, from right to left, and vice versa. It all depends on how you are measuring the angle. Suppose if you have an angle here, it is measured by keeping the protractor at this point where 0 is there, and we measure in this anti-clockwise direction, right from 0 to 180, 0 degree to 180 degrees. If you want to measure this angle, this side, we start from 0 degree from the left to the right. So only it is mentioned as vice versa here. Steps to be followed in measuring angles using protractor. Place the protractor on the angle in such a way that the midpoint of the protractor comes on the vertex B of an angle. Adjust protractor so that the line BC becomes a straight line of the protractor. Read the scale, start from 0, coinciding with the line BC. The point where the line AB comes on the protractor is the degree measure of the angle. Look at this. Protractor is placed in such a way that the center of the protractor lies on the point B. The protractor is adjusted so that BC lies over the straight line of the protractor, and 0 degree lies at C. Then we measure by left to right from 0 degrees to the line AB, line segment AB. The point where it touches the line segment AB gives the angle measure. Here after 70 there are two smaller lines, so 72 degrees is the measure of angle ABC, hence angle ABC equal to 72 degrees. Next concept we learn is related to perpendicular lines. If two lines intersect with each other and forms an angle of 90 degree, then they must be perpendicular to each other. Look at this figure. AB is a line segment, there is another line segment, MN, they both intersect each other at point N. And thus it is forming an angle measure 90 degree, and it is symbolically mentioned using this rectangle. We can write this angle MNB, which is same as angle MNA, and both these angles measure 90 degrees. We say that AB, using symbol we write perpendicular to MN, or MN is perpendicular to AB. I'll tell how to read that. It is read as AB is perpendicular to MN, or MN is perpendicular to AB. With the perpendicular line, we have another beautiful concept called as perpendicular bisector. As the name indicates, perpendicular refers to something where 90 degrees is formed. Bisector, what does it mean? Bisector means dividing into two equal parts. If a perpendicular divides another line into two equal parts, then it is called as a perpendicular bisector of that line. Here, in the context, line refers to line segment, not to be confused with that. Here, CD is perpendicular bisector of AB. It means that CD will divide AB into two equal parts, making AD equal to DB. And the angle measure CDB is 90 degrees. So there is a perpendicular and also bisector. With this, I conclude today's session. We shall discuss some more important topics related to understanding elementary shapes. That's all for today. Thank you.